Welcome back. Okay, so in your packet, this is problem number 12, but on my answer key, it's problem number 11. So I'm going to go with calling this number 12, but in the answer key, again, just be aware if you're looking at your answers prior, look at number 11. Okay, so I've again staged a little bit of information here. 12A is 3 marks, says show that points OA, B, and C form a square. Now back to geometry. In order for a quadrilateral to be a square, diagonals have to be equal in length and perpendicular. So I've gone and sketched OABC right here. Here's OB, here's AC, and I've done the math on finding their vectors, right? So all the points of B minus the points of O. Well, that's nice because O is just 0, 0, 0. Therefore, 6, negative root 24, and root 12 will just come out to be said thing. Okay, for AC, a little bit different. For AC, I have to take C minus A, so 0 minus 6, negative root 24 minus 0, and root 12 minus 0. So not that much more work, but just a little bit of attention to detail will get you where you want to be. Okay, so for requirement number 1, for a square to be formed, the diagonals have to be equal in length. What that would mean is that I want OB's magnitude to be equal to AC's magnitude. Okay, and it looks like the magnitude of OB would be equal to square root of 36. Okay, I'm just squaring all of the components. Plus 24 plus 12. That, if I'm not mistaken, is the square root of 72. Okay, and as you can see, it's going to be the same for AC. I'm guessing because they're asking you to show, you got to show the work, but you would end up getting 36 plus 24 plus 12 again. So, okay, we're good. Check on requirement number 1. Now let's show that the diagonals are perpendicular. And how we do that is we'd take OB and dot it, do the dot product with AC, and show that that equals 0. Remember that if the dot product equals 0, the angle between the vectors is 90. So we're going to take OB, which is 6, negative root 24, and root 12. Let's dot that with AC, which is negative 6, negative root 24, and positive root 12. And let's see what that equals. That's negative 36 plus 24 plus 12. Look at that. So OB dotted with AC. Oh my gosh, it's amazing. Exactly what they asked us to show. Showing that OABC is a square. All right, cool. So I'm planning on splitting this problem up because I think there are 6 or 7 parts to it. So it says in part B, 1 mark, find the coordinates of M, the midpoint of OB. All right, so since OB goes from 0, 0, 0 lambda steps in the direction of 6, negative root 24, root 12, what I'm going to do is I'm going to find the midpoint. Oops, let's go midpoint. Oh, that looks like a mu. Midpoint will be equal to 0, 0, 0 plus a half a step. Right, a half a step in the direction of 6, negative root 24, and 12. So our midpoint here, again, this is 1 mark, so I'm probably showing more work than I need to, would be 0 plus 3, which is 3. 0 plus half of negative root 24. Well, negative root 24 is equal to, would that be equal to negative 2 root 6? So if I divide that by 2, it looks like I get negative root 6. Okay, and then root 12 is equal to 2 root 3, so half of root 12 is root 3. So there's our midpoint of OB. We'll call it M. I guess I should have called it M. There you have it. All right, let's move on to part C. Show that the equation of a plane pi containing the square OABC is that y plus root 2z equal to 0. I'm going to go off camera for just a second and set a couple things up. I'll be right back. Okay, so showing an equation of a plane, we need a normal, because that normal allows us to then multiply by a vector on the plane, that of which we know 4 of them, because we've got 4 segments included in this square. If we dot it with the normal, we should get 0, and in terms of x, y, and z, we should be able to come up with the equation of the plane. Therefore, I know 2 specific vectors, and I'm going to pick ones that join at the same point, which is the origin 0, 0, 0. So I'm going to cross OA with OC to get the normal for pi. And OA, of course, was 6, 0, 0. OC being 0, negative root 24, root 12. I tried to pick relatively easy numbers that join at the origin, okay? Of course, that would be those 2. So when we cross those 2, our normal for pi ends up equaling, so our I component would be root 12 minus a negative, would be 0 minus 0, right? I would take, if I cover up my I component, I would take 0 times root 12, get 0 minus 0. So the I component, which we were expecting, right, because there is no x there, right, would be 0. Our J component, cover up here, remember it's going to be the opposite of whatever we get here, 6 root 12 minus 0. 6 root 12 minus 0. So let's do a little math on that. 6 root 12 is equivalent to 12 root 3. I'm going to kind of pare it down here. So that would be 12 root 3, simplifying it a little further. We're going to do something we didn't do in class before, but I'm going to show you how it'll equate to this. Okay, and then our K component, we need the opposite of that, right? Because we got to do, we got to do the opposite of that. Okay, cool, right? Because the J component's always the opposite sign. Excellent. All right, now for the K component, I cover up here 6 times negative root 24 minus 0. So 6 times negative root 24 would be equal to, let's go negative 12 root 6. Okay, negative 12 root 6. Okay, so we get negative 12 root 6. Outstanding. Okay, what I'm going to do here, because this doesn't look like what I've got here, right? This equation, this plane would have coefficients 0, negative root 12 root 3, and negative 12 root 6. What I'm going to do, and I'm allowed to do this, is I'm going to divide everything to its simplest form. So I'm going to divide everything by negative 12 root 3. Right, that would send the normal in a different direction at a smaller step length. So if I divide everything by negative 12 root 3, my normal pi adjusted would still be 0, but now it would be 1, and now it would be, what would that be, root 2? And look at how clean that's going to be, because I see my coefficients coming. Okay, now I'm going to take a vector on the plane, and I'm going to take point A and send it to an unknown point P. All right, so I'm going to call this vector AP. So all the points of P, which I don't know, are X, Y, Z. The points of A are nice and easy to work with, 6, 0, 0. I'm going to dot it with the normal, which is 0, 1, and root 2. Normal for pi, and when you dot it with the normal, it should equal 0. Therefore, I'm going to get 0x, and then 6 times 0 is also 0. So let's go 0x plus y plus root 2z equals 0. Clean that up. That's a little bit more pleasing. And there you have it. There is your equation of your plane. Now, I took a lot longer on there than you should have, right? But just so you can see this transfer in that adjustment in the normal, now you can simplify it down to said equation. Okay, let's do part D here in this video, and then I'll leave the other parts for the next video. So in part D, it says find a vector equation of the line L through M perpendicular to the plane pi. Okay, so perpendicular to the plane pi would mean it's parallel to the normal of pi. So this line will head in the same direction as the normal. Okay, so this line L is going to go through M, and I can't remember what M was. What was M? Let's go back for a second. 3 negative root 6 root 3. So goes through M, 3 negative root 6 root 3, and heads in the direction, same direction as the normal, parallel to the normal, perpendicular to the plane pi. And there you have it. There's an equation for line L. All right. If you got questions, shoot them to me. I'll be more than willing to help you out. Again, I'm going to follow up this video with the last 3 parts of this question. So we'll see you in the next video.